My name is AJ. Today I'm going to present the assignment on instrumentation system with selected sensor of piezoelectric sensor with my friend Weiren. Instrumentation is a collective term for measuring instruments that are used for indicating, measuring, and recording physical quantities such as flow, temperature, or pressure. It can be described in four steps which shown in the diagram. Transducer or sensor is the element in contract with a variable is being measured and giving an output depends on the value of variable. Signal conditioning is a system which improves the sensitivity and resolution of measurement quality from the transducer. SSD converter, which will convert the signal into a digital format. Signal presentation or display, which will present the signal that is processed by computer. Next. Piezoelectric effect was discovered in 1880 by Pierre Curie in quartz crystal. Then it was developed into the transducer that used piezoelectric effect to measure change in acceleration, pressure, strength, temperature, or force. Piezoelectric transducer is an active instrument will convert the force energy into electrical voltage. Quartz is preferred piezoelectric material compared to barium titanate and chloride malachite due to its high rigidity, high linearity, and negligible hysteresis. Next. After doing some research or comparison, the piezo pressure transducer with type of DP260 was from the magic sensing system was selected due to the extreme temperature capability from -70 degrees Celsius to 520 degrees Celsius, high pressure capability up to 315 bar, and the high reliability of the sensor. Next. The diagram shows the design of the sensor with the dimension, which will help in designing the system. Next. The table shows the static and operation characteristic for the piezoelectric pressure transducer when operating at 23 ± 5 degrees Celsius. From the table, the sensitivity of the sensor at 2 Hz is about 200 dB per bar. Typical dynamic measuring range is from 0.005 bar to 250 bar. Linearity of the sensor is plus minus 1% over dynamic measuring range. Acceleration sensitivity is less than 0.5 dC per G or less than or equal to 0.0025 bar per G. Resonant frequency is larger than 80 kHz and the frequency response from 2 to 15,000 Hz plus minus 5%. No subsequent calibration necessary for this sensor, and the sensitivity over the temperature range is plus minus 10%, while the over frequency range is plus minus 5%.
In the signal conditioning, first part is we use the function generator act as the input of piezoelectric, and next is the filter. The filter we use is active high pass filter, and the use of the filter is to remove the noise or low frequency. And the last part is the amplifier. The amplifier we use in our assignment is non-inverting amplifier, and the amplifier is used to magnify the output voltage from the filter and used for the display system. So the specification of the active high pass filter is the gain of the filter is equal to 1 and the cutoff frequency is equal to 2 kHz. While for the non-inverting amplifier, the magnification is equal to 101. Theoretically, the gain will remain constant after the cutoff frequency, but what we obtain is after the cutoff frequency, which is 2000 Hz, the gain will not remain constant, but it will remain constant at 11 kHz and decrease at 100 kHz. So in this part, we have three types of graph. We found that when the frequency is below than the cutoff frequency, the filter will attenuate about 95% of the input. While when the frequency is equal to 11 kHz, it will allow all the voltage to pass through. So to observe our signal conditioning more clear, we have record three types of data, which is the input voltage, the output voltage from the filter, and also the output voltage from the amplifier. And we use these three types of data to plot two graphs. Yes. So the first graph is input and output voltage of active high pass filter versus frequency change. So we found that the input voltage will remain constant at all frequency, which is at 0.007 watt. But the output voltage will increase as the frequency increase, and it will remain steady after 11 kHz. The last graph is the output voltage of active high pass filter and non-inverting amplifier versus frequency change. And we found that the magnification of non-inverting amplifier is constant before the frequency change to 4 kilohertz and it will decrease after 4 kilohertz. So in the conclusion, the active high-pass filter, the cutoff frequency is equal to 2 kilohertz and it will filter the noise below than the 2 kilohertz. And the non-inverting amplifier, the magnification we use is equal to 101. And it is used to magnify the voltage before use in the display system. And the shortcoming of the system is our non-inverting amplifier magnification is decreased after the input frequency is equal to 4 kilohertz. So that's all for us. Thank you.
Thank you.